Thank you. It's really an honor to be providing an opening presentation for this exciting week. And what I'd like to do in this presentation is provide a foundation of what we know overall on climate change right now, what its impacts are, and what the options for response are. All of what I present will be building heavily from the last assessment by the Intergovernmental Panel on Climate Change, which takes scientists from around the world in interaction with reviewers from around the world and all of the world's governments in developing definitive statements on what we know and what we don't know about climate change. And what I'll highlight at the start is that the foundation I'm describing is also the foundation that's being used by negotiators under the UN Framework Convention on Climate Change in building up to the Paris Agreement that will be decided in Paris, December this year. A big emphasis in the IPCC's fifth assessment report is that when we think about climate change, the climate challenge, our options for responses, it's really helpful to think about responding to climate change as a challenge in understanding, managing, and reducing risks. This theme of climate change as a challenge in managing risks is going to be like a heartbeat throughout this presentation. I'm going to show the ways that it can open understanding of the problem of climate change and also the solutions. But to help me introduce this theme, I'm going to turn in 3 snippets throughout the presentation to an animation we developed in Working Group 2. If any of you ever work with Michael Mastrandrea on campus, you will be introduced to his voice right now.
Climate change poses risks for people, ecosystems, and economies. Think of risk as probability times consequences. Some risks are high because the outcome has a high probability of occurring. Other risks are high because the consequences are very severe, even if the probability is low. Risk results from the interaction of hazards, exposure, and vulnerability. Let's take a look at what these terms mean. A hazard is an event or trend like a heat wave, wildfire, or coastal flood. Exposure is people, ecosystems, or assets at risk. Finally, vulnerability is susceptibility to harm or limited ability to cope and adapt.
So this is laying out risk in a changing climate as emerging from the overlap of climate change, societies, not just the physical trigger from the climate system, the hazard, the heat wave, the drought, the flood, but also how that hazard intersects with the vulnerability or susceptibility to harm and exposure, assets at risk. There are a variety of reasons why putting this focus spotlight on climate change as a challenge in managing risk can be really helpful. First of all, there's the idea of complex interactions. The fact that if you want to say, what is the risk of climate change for species extinction in 2100, it's not just about climate change, it's about how climate change is interacting with habitat fragmentation, pollution, overfishing, all of these different stressors interacting to produce any one outcome you're looking at through the lens of climate change. Another reason why risk is really helpful is it connects our current experiences with the climate system, recognizing that climate touches on almost every part of the human endeavor, to possible outcomes in the future. So here in California, we're experiencing our 4th year of a very intense drought. Irrespective of the role of climate change in that drought, which you may hear about more this week, you can look at that drought as revealing our susceptibility to an intense physical stressor. We see communities in California, a major economy, that are without running water. We see the classic battles of fish, the delta smelt, versus our major economies, our agriculture in the valley. So climate change as a challenge in managing risk provides that bridge. It also helps us look at the low probability events, including extreme events that can be really important for shaping outcomes. So when you get in a car, you put on a seatbelt, not because you are likely to get in an accident that time, but because of the possibility of that high consequence outcome happening. Climate change is really similar, and when we think about things like the potential for large amounts of ice sheet loss, many meters of sea level rise over a century, that's that kind of low probability event where we're looking for the changing risks. And the final reason why climate change is a challenge in managing risks is helpful and is particularly relevant to the diverse expertise in this room is that we think about risk in almost every aspect of our human endeavors, whether it's security, insurance, business, law, government in different forms. And we have a whole lot of tools for understanding risks, evaluating possible response options, and taking smart actions. Those same kind of tools can be applied to the climate challenge as well. In terms of animating this particular figure, I'm going to go back to the video for another 30 seconds.
Risk of climate change impacts emerge from the interaction of hazards, exposure, and vulnerability. The frequency and intensity of hazards are affected by both natural variability and anthropogenic climate change. Now, natural variability is our climate's natural tendency to vary from day to day or year to year. Anthropogenic climate change is different. People are changing the climate, especially through the emissions of heat-trapping gases. This human-caused climate change is warming the air and the oceans, melting snow and ice, and changing the occurrence of extreme events like heat waves and heavy rain. People are important in determining the risks of climate change. This is because society and its pathways also influence risk. These socioeconomic processes include changes in people's livelihoods, economies, and well-being over time, actions to reduce the amount of climate change that occurs and to prepare for impacts that can't be avoided, and the policies and operations of governments. Impacts can affect both society and the climate.
So this figure really represents the problem space in a changing climate, the way that risk emerges from the overlap of these different factors, the ways that the resulting impacts affect our societies, our economies, and our ecosystems. What I'm going to do in the rest of the presentation is walk through this figure and provide you with some of the underpinning conclusions from the IPCC, really starting with the world around us. But in stepping through this problem space, what I hope to convince you is that this view of the climate challenge actually can become the entry points for solutions. Every issue that contributes to risk can also become an entry point for responses. So starting with the physical climate system in the world around us. In 2013, the IPCC confirmed what it had concluded in 2007. Warming of the climate system is unequivocal. Since pre-industrial times, we've seen about 1 degree Celsius of warming around the world. This map shows that warming, and I'll just point out a few key features. First of all, you see some white spaces on that map. Those are places where if you try to say, based on our observational records since pre-industrial times to the present, we don't have enough available data to say exactly what the trend is. If you're thinking about relevance to Paris, the fact that most of Africa has very limited observations puts a real constraint on our ability to say what the impacts will be, and puts a lot of pressure on saying, well, what is fairness in that sort of context? Another thing that is interesting is that one of the few places that has not had significant warming in the entirety of the US is DC. If we think about the entirety of the climate system, all of the energy, heat we are adding to it, this figure is really helpful in providing an orientation. What it shows in those very large blue wedges is that ocean warming is responsible for most of the energy coming into the climate system. We tend to be really fixated on the amount of warming in our atmosphere, that 2 degrees Celsius warming above pre-industrial times. The heat going into the atmosphere is this very fine little sliver. So this helps provide an orientation, and for all of the discussions on, well, has there been slightly lower rate of warming over the last decade or not, this helps emphasize that the climate system is changing dramatically, especially if we take this big picture view. Turning to the world around us, the Working Group 1 assessment of the IPCC found changes in the atmosphere, warming of our air, warming of our oceans. The oceans are also, as the ocean scientists like to say, becoming not only hot, but sour and breathless. Reductions in oxygen, increases in acidification. We're seeing changes in many different types of extreme events, extreme heat, drought, flooding, sea level rise contributing to risks. We see changes in the water cycle, where rain falls, where it evaporates more intensely. We're seeing massive changes in our frozen ground. We've been thinking about that a lot in California with the reduction in snowpack, but we see reduction of glaciers around the world. We also see rising sea levels, magnifying risks when storms strike shore. Putting these pieces together, the IPCC concluded that human influence on the climate system is clear, and we increasingly understand the causes of that. Our emissions continue to rise faster than ever before, tied to those energy increases you saw in the previous presentation. This figure shows our increasing emissions over the last few decades. Most of these emissions are CO2 from industrial processes, fossil fuel emissions. There are also substantial emissions that come from land use change in agriculture, for example, as reflected in those methane and nitrous oxide wedges. Those are emissions that can be particularly hard to grapple with in terms of reductions. The challenge in terms of thinking about this kind of figure is, can we decouple these emissions from our economic growth? 2014, and 1 year does not provide a robust sample, but it was an intriguing year in that it was the first year where our emissions did not rise, but our economies went up. That's the type of decoupling we need to be thinking about as we head into the future. This is a decomposition of the drivers of emissions growth into 4 major factors that you will likely be learning about this week or in classes to come. And what this shows is that population and economic growth have been the major drivers of our rising emissions. They have outweighed our increases in energy efficiency. And what this little blip of a red square shows from here to there is that the decarbonization of our energy that happened over the past decades was reversed in the first decade of this century due to increased use of coal. Due to this human influence, we see impacts. A big advance from even 10 years ago is that we can look at the world around us and say that the climate changes that have already occurred have had widespread and consequential impacts. This is a visual summary showing impacts on every continent, from the mountains to the seas, from the tropics to the poles. And as part of what represents the novelty in our scientific knowledge right now is all of the red on this figure. The red shows impacts that we can link to climate change for human and managed systems: agriculture, well-being, health, economies, indigenous peoples. Looking in particular at North America, these are impacts like reductions in glaciers, reduction in snowpack, changes in river flow, coastal erosion that we see in Canada and Alaska. There's been some coverage of that with the president in Alaska over the past week, where, for example, as you lose sea ice, you increase erosion in the places that become more exposed. We've seen impacts like species in the oceans, on land, changing where they live, when they migrate, when they reproduce. We've seen a lot of tree mortality linked to climate change, and as particularly relevant for our experience this summer, we have seen increases in wildfire. That red impact there shows impacts on indigenous peoples in the Canadian North Arctic due to loss of Arctic sea ice. This type of assessment is grounded in many different studies from around the world. You're going to hear from David Lobel, I think maybe tomorrow morning or the next day. And this is a figure he produced in the assessment by the IPCC. As we heard this morning, many Stanford professors have participated in this assessment process. And what this shows is that if you look at all of the available studies on climate change impacts on the major commodity crops, what we see is that climate change has acted as an anchor. Yields have not gone up as fast as they would have in the absence of climate change. This is particularly the case for wheat, which is very temperature sensitive, as well as for maize. As we think about these impacts of climate change in the world around us, I'm going to return to this idea that the impacts of climate change are not just due to climate. It's key to understand the human component of vulnerability and exposure in understanding what these changing risks are. This is the idea that people, societies, and ecosystems around the world are vulnerable and exposed to climate change, but in different ways. These people are in a refugee camp in Sudan. You could point to that level of marginalization and lack of capacity in that situation and say that that represents high vulnerability. Much focus has been looked at the ways that poor governance or poverty can combine to amplify risks. But really essential in viewing climate change as a global issue is recognizing that wealth is not necessarily protection. This is this is New York City after Hurricane Sandy. New York City has seen a foot of sea level rise. Its subways flooded by about 2 inches. That was the amount of sea level rise that was necessary to cause that major impact. If we think about the $65 billion of losses revealed in an event like that, where climate change could be something viewed as something that is amplifying risk, we really see profound vulnerability and exposure around the world. got one more conclusion about the world around us, and that is that adaptation, or people, societies, communities, firms, becoming more prepared for the impacts of climate change, encompassing climate change into their thinking and planning for the future, this type of adaptation is already occurring. The interest here is perhaps that if you step back a few decades to the start of the IPCC, the start of international negotiations on climate change, although not the start of the recognition of climate change as an issue. If you go back a few decades, adaptation was almost a dirty word. It was viewed as something that could detract attention from mitigation. And in this time, it was largely thought that we could solve the climate challenge really easily. We could prevent future warming. Increasingly, though, we recognize that we're already seeing those impacts of climate change as I described, and that even with our most ambitious mitigation, we're going to see more warming that will affect people around the world. So as we look around the world, we increasingly see these different types of adaptation, which can be infrastructural adjustments, flood barriers shown here in the Netherlands, really smart adaptations, for example, with the London 10 barriers that's planning for different levels of sea level rise that could happen through the century. We see a lot of community-based efforts, for example, planting mangroves here to protect a coastal area. We see lots of focus on the ways that early warning systems can help make sure people are prepared for heat, for flooding that may occur. We see attention to the ways that basic public health systems can make people much more robust in the face of an extreme event occurring. Turning to the future, the assessment by the IPCC highlights that increasing magnitudes of warming increase the likelihood of severe, pervasive, and in some cases, irreversible impacts. Continued high emissions increase risks in a bunch of different ways, and I'm going to step through some of the major ways that the IPCC found to summarize these in a coherent package. But where I'll start is with timeframes for adaptation and mitigation benefits. What we see in the top plot here, and that black squiggly line, is that observed warming to date, a little under 1 degree Celsius. In the blue plume, we see a scenario of very ambitious mitigation. Mitigation starting tomorrow, essentially, that will limit warming in this scenario to under 2 degrees Celsius by the end of the century. In red, by contrast, we see a scenario of continued high emissions, which would take the world to over 4 degrees Celsius by the end of the century. Those two possible climate futures, the world of ambitious mitigation is depicted here, world of continued high emissions here. And what we see is that even with incredibly ambitious investments in mitigation, the amount of warming does not diverge immediately. Over the next few decades, there's some amount of warming that is locked in, baked into the climate system, due to our emissions to date, and also the fact that we can't immediately drive emissions to zero tomorrow. By contrast, the actions we take over the next few decades will be pivotal in shaping the amount of warming that happens in the second half of the 21st century and beyond, which you can think of as an era of climate options. In this view, I'm returning to that map I started with that shows the 1 degree Celsius around the world increase that we've seen so far. And what's helpful here is that this is showing warming to date, and this is showing down here warming from now to the end of the century. The fact that those maps are the same color means that even with this very ambitious mitigation, we're going to see one time again how much warming we have already seen. That's that baked-in warming that is relevant to any set of responses that you think about. By contrast, this is the amount of warming that would happen in that world of continued high emissions. And there we could say that almost every system on Earth, whether it's water, ecosystems, livelihoods, poverty, urban areas, rural areas, will be taken far away from its current experience with the climate system, to the extent that in terms of our ability to model exactly what will happen, all bets are off because so many systems simultaneously would be moving away from the current climate. In the next 2 slides, I'll take a few deep dives again into the data, showing what some of the analyses of changing risks look like. For any of you oceans fans out there, this is a plot of projected redistribution of fisheries catch potential in the ocean. That's basically if you go out in a boat, how many fish might you be able to catch? Showing that in some places in blue, you get increases, and in other cases, particularly in the tropics, you see substantial decreases. And what this shows is that this global redistribution of fisheries, paired with biodiversity reductions in sensitive regions, again, particularly in the tropics, for some people, and in recognizing again in the tropics that there's substantial dependence of livelihoods and communities on those types of coral reef-associated fisheries, the combination of this redistribution plus biodiversity reduction really threatens some of the ecosystem services we've come to rely on. again, going back to a David Lobel special, this is a projection, a set of projections of every available crop yield increase through the century, every available crop yield projection through the century. And what we see in the kind of yellow to brown colors are projected decreases in crop yields. And in blue, we see projected increases. So again, we see this patterning of risk through the century, but the magnitudes are helpful. In the 2030s, about 10% of projections are for increases of yields of 10% or more. And even in this time frame, 10% of projections are for yield decreases of 25% or more. As you march through the century, those disparities increase. And for levels of warming like 4 degrees Celsius, combined with increases in food demand, we're looking at very substantial risks for food security around the world. Again, particularly where there's limited access and availability of food. The assessment in the IPCC focused on something called key risks. These are risks that deserve the fullest measure of society's attention based on a series of criteria relevant to understanding irreversibility of outcomes, limited potential to reduce risk, persistence through space and time. And the assessment of the key risks looked at how they're changing as you go from the present to the near term with that baked-in warming, and to the longer term for that scenario of ambitious mitigation versus continued high emissions. The assessment considered both what risks would be like at our current levels of preparedness, and also with substantial further investment in adaptation. And it marched around the world, showing that there are many commonalities in the types of risks that are most important in different places. These are risks associated with water insecurity or food insecurity, risks associated with extreme events or affecting human health and well-being, risks for biodiversity. And what the assessment did was focus in on each region and highlight some of the risks that are most salient, most pressing in different regions. And so for the US, Canada, Mexico, for example, some of the risks highlighted were associated with wildfire, associated with extreme heat events, and with flooding, both in coastal and river areas. And the assessment really highlighted the way that many different types of responses can help reduce those risks, starting in the near term, often with co-benefits for livelihoods at present, and extending out into the future. The grand finale in the risk assessment was something called reasons for concern. And these are reasons for concern from a global scale. And there are 5 of them because values matter. There is no one way to say what is at stake in a changing climate. Across these different reasons for concern, if you say, I care most about the present versus the future, the risk of outcomes for the poor versus the rich, risks of outcomes for nature versus economies, extremes versus averages. All of those different axes give you a different picture of what's at stake and when the risks may, from your perspective, become intolerable. And so what we see on the left here is that projected warming, continued high emissions, ambitious mitigation, and we see that leading to risks throughout the century. And this is really where you can see that conclusion of continued high emissions leading to severe and pervasive impacts at a global scale within this century. I'll dive in just a little bit to these different reasons for concern. There are things like risks for unique and threatened systems. These can be ecosystems, cultures, landmarks that may not extend very far geographically, but that may be particularly at risk. Risks associated with extreme events, as we've discussed quite a bit so far. There's the unfairness factor in a changing climate, the fact that any outcome that happens will have uneven impacts. There will be people who are much more affected than others. There are global aggregate impacts, such as those for the economy overall, for biodiversity overall. And then there are what I call the game changers, the potential for large and irreversible changes, such as that potential for large amounts of sea level rise, up to 7 meters, on a multi-century timescale due to ice sheet loss. This cartoon came out after the synthesis report was published in last November. And I object to the gender stereotyping here, but it's a mother serving dinner, and she says, your goose is cooked. And what we would really say is the message probably is more nearly, your goose is almost cooked. The governments of the world have agreed on a long-term goal of limiting warming to 2 degrees Celsius or less. And that or less is important because over half of the governments think that 2 degrees Celsius is too much and it should be something more like 1.5 degrees Celsius. But if we say, can we limit warming to 2 degrees Celsius? Well, we know that if you looked at every country of the world and every business in those countries and the governments and communities and urban areas, and everyone started mitigating immediately, putting all of the available technology on the table, using some powerful tools like a global carbon price, It's feasible to limit warming to 2 degrees Celsius, but the challenges come from things like technologies. If we don't meet that perfect world outcome, will we have negative emissions on a global scale? They come from economic challenges. Can we break that linkage between rising emissions and economic growth so that that doesn't have to be an either or? And it comes from challenges of governance and institutions. What this figure shows is a schematic of many hundreds of scenarios of continued high emissions based on energy economy models of what those trajectories might be, and then you can calculate from them what emission reductions would have to be and how much they would cost. In contrast, we see these scenarios of ambitious mitigation. And I'm going to point to one point here. If you remember one thing from my talk, this is it. To limit warming to 2 degrees Celsius at a global scale, we need to hit negative emissions, net negative emissions at the global scale within this century. But this relationship between cumulative emissions since pre-industrial times and the amount of warming is nearly linear. So what that means is that no matter what our goal is, whether it's 2 degrees Celsius, 2.2 degrees Celsius, or 7 degrees Celsius, we will need to limit we will need to limit emissions to 0 at a global scale. So that really means, unless we want to create inferno on Earth, it's not a question of if we limit warming or if we hit 0 net emissions, but when. And I think this has really been a focusing element for governments as they're heading towards Paris. There is a finite pie, a carbon budget, and we're really thinking about what's fairness when you think about how that remaining budget of emissions for any global warming target can be allocated. I'll end with a few hopeful points. If we look at emissions strategies around the world, what we see is that national legislation and strategies now covers 67% of emissions globally. That provides a framework for thinking about reining in emissions, but we haven't yet seen the tightening of the knobs really necessary to drive those emissions down. It does provide the starting point, though. And when we think about responses to climate change, both through adaptation and through mitigation, what I will argue is essential is that it's not just about costs and trade-offs. Because climate change impacts affect almost every aspect of the human endeavor. They are so tied to social aspirations, what people want in their lives, their careers, for their families. There's a huge opportunity to view climate change as a way to build a better world, a way to make our economies more robust, our communities more vibrant. I'm going to go back to this video for one last little clip to take a look at that.
There are many ways we can reduce and manage the risks of climate change. There are low regrets options that reduce vulnerability and exposure, such as building safer homes, improving irrigation and drainage, and restoring ecosystems. There are also many tools available for anticipating impacts and reducing risks. Values, goals, and learning are important in responding to climate change. Reducing emissions of heat-trapping gases decreases the amount of climate change that will occur. The Intergovernmental Panel on Climate Change Working Group 2 Fifth Assessment Report assesses a wide variety of approaches for responding to the risks of climate change and building a more sustainable world.
So here's this figure I started with, risk in a changing climate emerging from this overlap of hazards, vulnerability, and exposure. And this is the problem space, but as I described, it's also our solution space. It's our opening, our entry points for responses. There's mitigation, addressing the root of the problem, turning the tide on our rising emissions of heat-trapping gases. There's that importance of recognizing that there's so many ways we are vulnerable to our current climate, and that good governance, good business leadership can very naturally decrease our vulnerability, decrease our exposure through things as mundane as improving drainage within cities. There are many ways to assess risks, to understand them, and recognize that perception of risk can be a really powerful lever in terms of thinking of responses. Psychology, culture, attitudes are really important in shaping the risk landscape. There's the importance of recognizing that our development pathways, the way our societies around the world develop over the coming century, will be very tied to energy. And as you heard, sustainable energy for all needs to be a rallying cry in a way that is done with low emissions. Adaptation and mitigation interact, and they will continue to interact. with co-benefits, synergies, and also trade-offs. Putting those pieces together with sustainable development is the opportunity in the future. And finally, there's the importance of recognizing that any decisions about the future are decisions made under uncertainty. We don't know what will happen tomorrow, and we don't know what will happen exactly with climate change added into the picture, but we have a good scientific understanding for assessing the risks and making smart choices. The last data slide that I'll end with is this one. This is really a challenge for all of you in this room. It's an opportunity. If you say, what are our energy investments in our energy systems globally right now, it's over $1 trillion. Based on those energy economy models that I showed in that picture with the different plumes, you can look at cost-effective ways of achieving change. So these are investment changes for scenarios that give us a good chance of limiting warming to 2 degrees Celsius. And we could say, oh no, this is horrible, we have to change what we're doing. Or we can say, look, here are business opportunities. Here are the entry points for solutions. We need to increase our energy efficiency. We need to turn towards energies that are low emissions, zero emissions, whether that is nuclear, which brings its own challenges in terms of implementation, or renewables, which has been rising rapidly, as we also heard so far. Can we do carbon capture and storage and actually change the focus on fossils as a problem to something that we could work with more substantially in a low emissions future? And how do we think about fossil fuel plants without carbon capture and storage, and some of the ways that those are staying in place? Can we change the oil companies, instead of the ones dragging the feet, to the ones who are going to say, we can help solve this problem? So this is a view of the way that the energy investment landscape will change in the future, and I think you're going to dive into this in so many different ways this week. But what I will just end with is this idea of climate change as a challenge in understanding, managing, reducing risks, where there are many entry points for solution on the energy side, on the impact side. This is about communities, universities, governments, and our collective future. Thank you, and I believe I've got lots of time for questions.
So is it first? Thank you very much for that talk. My name is Derek Turner, and I'm with the business school. I understand that the Copenhagen conference a few years ago was somewhat disappointing. I'm curious what makes you optimistic about Paris this year, and maybe what's changed to make your view more optimistic.
Okay, there were tons of lessons from Copenhagen. So Copenhagen was the meeting of the Conference of the Parties that happened in 2009. And it was the time when people were saying, okay, we're going to put in place the successor to the Kyoto Protocol. It was somewhat of a flop in that there was a noted Copenhagen Accord, but there was not a binding agreement, and there was no successor to the Kyoto Protocol. Governments largely viewed that as something where they had not at all achieved what they wanted. And it's still going to be negotiations by consensus of all the world government, but there's been a substantial shift in strategy. So since about 2011, there's been intensive work by a group called ADP. This is really UN babble, but it stands for the Ad Hoc Working Group on the Durban Platform for Enhanced Action. And for years now, this group has been working on the successor to the Kyoto Protocol, what will become the Paris Agreement. So what is different? I would say that the single thing that is most radically different in the negotiation strategy this time is that it's a bottom-up approach. Instead of saying this is only going to be mitigation action by developed countries, which is tied to why the US did not ever sign the Kyoto Protocol, every government in the world is putting forward their national pledge of both their mitigation action and their adaptation action. These national pledges mean that there's this embedding of common but differentiated responsibility, the idea that what the US does sure better be really ambitious, and it is, and that pushed forward with the agreement with China. But at the same time, you've got Ethiopia aiming towards zero emissions in the next few decades. So it's really a unifying aspect where there's going to be different capacity support needed in these different contexts. That said, last week was the last series of this ongoing negotiation. There'll be one more week, and then Paris, that one more week of negotiation will be in October. The biggest issues are still on the table, and it's basically how do you think about the overall ambition? Will they hit 2C? This is critical in that what is on paper in these pledges is not on the face value going to take you to 2 degrees Celsius. No way. Banish that thought. The idea is starting to bend the curve. And there's this deep fundamental questions in terms of understanding what energy development, technology development might be on a century scale. I think you're going to hear more about this next. That it makes it actually very hard to say, is that sufficient? But there's this big desire for ambition, and tied to that ambition, there's the perennial question of fairness. How do you think about the finance that's needed across countries? How do you create an enabling environment so that everyone can achieve their aspirations? So there will be battles down to the wire, but the really big difference from Copenhagen is that we will be entering Paris with many different national pledges already on the table. So it's not as if we've got nothing, we've got tons already. And these sort of big countries leading with the US-China agreement of last November really has helped create a momentum towards a view that it will be different. It won't be everything, but it will be increasing our ambitions towards solutions. Oh, I guess I'm not the mic, sorry.
Okay, sorry. Hi, thank you for the presentation this morning. I'm JY, and I'm in the humanities. And I think both you and Tom have danced around this issue, but why are so many politicians and policymakers in DC bad at science? Like, what political and cultural factors in the US fuel this widespread denial of climate change? And do you think we can see American and Chinese leadership on fighting climate change in the upcoming decades?
Okay, so I'm an optimist in terms of US public opinion on climate change. I think if you say, do you believe in climate change, that is often perceived not as a science question, but as a beliefs question. It's about who you associate with. It's about what your culture is, what your political party is. I think we see that changing. The response, I'm not a scientist, is actually kind of an end game for Republicans saying that they don't believe in climate change because they don't believe, they're not experts in insurance, they're not experts in security. It's not a forever strategy in terms of saying what their response is. I think there are many fascinating analyses of what has contributed to this dimension of US public opinion. Working for an international group like the IPCC, I can say it's very Anglo. Canada, UK, Australia are some of the powerhouses of skeptic movement. You just don't get that in almost every other part of the world. And I think US is going to get with the program pretty quickly. I think we're looking at the sort of paradigm shifts that have happened in recent rulings with the US Supreme Court, for example. And so I'm optimistic that that can change. It's not necessarily easy. There are interesting things like if you say to someone, do you believe in climate change? Versus, do you think scientists believe in climate change? And you can go really technical with those questions. Often you'll get an understanding of the science that is not connected to the beliefs. So this is about paradigms, how people view the world. There are many embedded interests that I think have helped shape that. But I also think we're ripe for change.
Hi, I'm Sebastian Serra, also with the business school. I'd be curious just to hear a little bit about your experience working at the IPCC. In particular, what kind of pressures exist kind of from a policy level in what kind of message you communicate in the IPCC reports, and whether there were instances of things that you wanted to publish or say in certain ways, and whether you had pressures that kind of prevented you from being able to do that or not. I'd just be kind of curious about what that dynamic was like.
Great question. Okay, so the IPCC, you could say, is all about process. It's a very extensive process that enables governments to say, follow our rules, have multiple rounds of review by anyone in the world, and we'll take these reports to be the definitive statement on what we know on climate change. Now, this question of, is there political distortion, has been raised mostly with regard to what is the most unique aspect of the IPCC, the line-by-line approval of the summaries for policymakers. These are short 25-page documents where co-chair Chris Field is up there. I'm at his right as his science advisor, and we've got experts on the left. And it's a sea of governments, UN style, and anyone can raise a question. Prove it. I found this one statement in the report that seems to contradict your conclusion. Demonstrate its accuracy. If I look at this finding compared to what the IPCC concluded in 2007, it seems contradictory. Or this statement is open to 3 different interpretations. So this sort of discussion, interrogation of the scientists, a conversation of sorts, goes on for days, and it usually goes on for nights as well. And it's incredibly intensive. As a scientist, I can say it's maybe the week, or at this point, the 3 weeks of my life that I have felt most alive. You do not sleep, and you are on at every single moment. But it's also incredibly challenging, and there has been some intense angst, and there are always people coming out of these negotiations and saying, I didn't get what I wanted, and this was really complicated. The question is there political distortion? And I think what you can argue is that anything that goes into the summary for policymakers has to be said by the scientists, this is scientifically accurate. The place in the AR5 where that became most controversial is that if you can't get consensus, it can be the case that material is dropped from the summary for policymakers. Negotiating that science policy interaction requires not just scientific credibility, it requires listening, it requires saying, here we've got Saudi Arabia, Venezuela, Ethiopia, Sudan, China, and they all have the same concern. As a scientist, can I understand the valid points that they're making? Can I understand where there's legitimate confusion? And can I understand where I need to totally hold my ground and say, no, scientifically this is right? So there are challenges in this process, but the really unique thing about it is that, assuming everyone survives, which they usually do, you leave that room and the governments take home this product as the definitive statement of what we know. It has unique standing for governments around the world in really creating a statement of, here is the scientific baseline of our understanding today that can become a foundation for future action.
Hello, my name is Dante. I'm from the Materials Science and Engineering Department. And I had a question. On slide 70, you have a graph showing change in investments across different sectors. I think that was the one you just showed 2 slides ago. I'm kind of surprised that nuclear is so low. Are these projections based on models or current investments? And I'm guessing, is this projection based on scientific thought? Do scientists believe that nuclear has little potential investment? Or is this based on kind of the different type of things that?
Great. Okay, so all of these results, along with a whole bunch of the results from the Working Group 3 report, come out of energy economy integrated assessment models. So here on campus, check out the work by John Wyant. And basically what these are doing are finding cost-effective pathways to given goals. So you're gonna say, let's constrain warming to 2 degrees Celsius, embed rules of how we understand economies to work. Then we've got some huge uncertainties, absolutely huge uncertainties. What will the technology cost curves be through 2100? What will economic growth be through 2100? And really, no one knows exactly what the technology costs will be in 2100. No one knows what global GDP will be. But these are tools that are enabling in a quite sophisticated way an understanding of the sensitivity to different factors. So I can put you in touch with some people who could really describe in depth how nuclear costs are treated within it. They generally run these first through kind of first best world scenarios where you assume all technologies are on the table, all governments participate right away, and there's a global price on carbon. They then shave off aspects that get you to different second best worlds. For example, no nuclear. Significant delay by some governments in deciding to invest in mitigation. Or importantly, ruling out negative emissions, our ability to extract CO2 from the atmosphere. So you can say that these are all resulting from cost-effective, the cheapest way to get to different goals through these quite stylized but important for understanding sensitivity type of model. Maybe just, I think I have one more question. Is that right, Lee? One.
Hi, I'm Sai. I'm from the School of Education. This is regarding adaptation. So I'm assuming that most ideally, to reduce risk, communities, businesses, economies would work with each other to adapt to climate change. But for example, in developing economies where that recognition doesn't exist, which entry point has the highest potential for adaptation?
So I might slightly disagree with the premise of the question in that I would say that in many developing countries, even least developed countries, there's a substantial recognition, maybe an even more intense recognition of vulnerability to current climate. So if you don't have irrigation and a drought happens, people are starving, right? That's an incredibly intimate connection with the weather that we don't get here in California. You know, our agriculture has been affected. Is that really affecting our food prices, our way of life? Not really. So I think there is a big recognition of the ways that food insecurity, water insecurity, health outcomes all intersect with the changing climate and present opportunities for adaptation. But there are big, big challenges. A, how do you make it happen? If you have a government structure that is not necessarily achieving those outcomes to start with, you've got a whole lot to tackle in order to additionally address climate change. Another big question is even measuring the effectiveness of adaptation. Okay, for all of you people developing projects out there, measuring the effectiveness of adaptation is almost doesn't exist. It's actually incredibly hard to say at a global scale, are we more prepared for the climate than we are right now? Emissions provide a very easy metric for mitigation, but understanding how resilient, how robust are societies, economies, there are many different metrics and they give you very contradictory and not always helpful results. So there are things like, do we see meaningful change that present challenges? At the same time that there's recognition that almost any place you start, you have opportunities for addressing risk through adaptation. Okay, thank you.